Alright, the night all. Alright, so I don't want this to take too long, so I look to start. Alright, so yeah, the first midterm tomorrow is 25%, so we have a 25% and a 25% probability, and then a 50% final, right? So that's running through the stuff that you need to know, what that she typically brings. Then we call it at the end, you could take the rest of the night to practice and stuff. So majority of you should have my number, so you could always just send what you do and message me and I'll just give you feedback on it. So I don't want this to take too long. Alright, also, anyway, I'd like to start. So you all should have this. If not, I will send it to you all and you can share it around. This was last year paper, but the question one was the same because she brought question one that year, and then the year you all have, which I believe is this year, which was last year, which was my year, was the same question. So she likes to bring them. So if there's one thing by now, you all should be able to do everything here. The tricks, so I'll just go across to this here, because that's the answer. So you all should know the trig form of the Fourier series, the equation for A naught, AK, Bn, this must be A naught on 2, because that is a DC component. Right, you should know the equation for An and Bn, the harmonic form, you should know the equation for the harmonic form, the equation for Ck and theta, okay? Right, you can just memorize this, right? It's 3 marks. And also, and lastly, the equation for the complex exponential form of the Fourier series, right? Which is f of t and the equation for x of k. Right, this is just something you can memorize and you had to know regardless. Alright? And then the second part is your proofs, right? So there are two main proofs, which is going from the trig to the complex and the trig to the harmonic, because there's normally use the trig to get to the other forms, because the trigonometric form is the most basic form or the most fundamental form of the Fourier series. So it does use the trig to go to the exponential and the harmonic form. So you need to know those two proofs, and the proof that has been weighted higher is the trig to the exponential form of it, right? Which I'll go through this one, so you all to know. This one, part C, I already did it on my YouTube channel, so you can check it out. This one is the shorter one and more straightforward, which is why it's for less marks. And the relationship, let's see if I can bring that up here. Alright, so I'll send you all this document. Right, so the relationships, AK, BK, you can get this from the triangle, the normal arm. So theta K, AK, BK, and CK. Like once you know this, you can get everything here. AK is deriving it, which is the horizontal component. So it would just be CK cos theta K, and then BK is CK sine, right? This is like the most important triangle in the course. And CK and theta K, this one has come from the harmonic form. CK is Pythagoras theorem, square root of AK squared plus BK squared. This is basically the same thing I did before where you memorize. So at that point it's just redundant. And theta k is minus tan inverse of BK and AK. Alright? And this one here, secant 2 is e to the j theta. Right? This is the reason why when you plot in the double-sided spectrum, the magnitudes are half. Because you could go through the exponential form to get the double-sided. And when you do that, you end up with the magnitudes reflected, but all divided by 2. So these three things, as I said, if you memorize the first part, you will know this by default. Right, and that is basically question one. Right, so what I'm going to do now is go through the proof for the exponential from the trig form. And then from there, I'll just go into the graph questions. And other than that, I'll just rock back for any questions, and it shouldn't be a long session. I only have to practice and stuff. So I look to start. Right, so I so the first yeah. Right, before I start, do you have any questions? Before I get into it, or I could just run it. Alright,
Proceed.
says yeah. Somebody asking
Yeah.
something? Yeah, yeah, yeah.
I have a question, right? I
Yeah.
asked yesterday, but I'm not too sure. I don't know how to proceed with it, but and you know in 2023, the one you all did, the question two,
Hmm. That's not
that
let
is
me
where they
let me bring it up here, 'cause I think I have it.
yeah,
Uh that is this paper.
yeah,
This one?
question
Yeah,
two,
yeah, question.
magnitude and phase.
Yeah. Uh-huh.
So basically, and you know when you're proving the harmonic series for Fourier, the theta k is b minus theta k.
Yeah. You're talking about the proof.
Yeah,
Yeah.
but when you're using it, right? If you use the CK plus open bracket 2 pi f of k plus theta k instead of minus theta k, would
2
that
pi
uh,
k.
would that be wrong?
Okay, so remember with the harmonic form, right? That does give you a single-sided spectrum, meaning
Yeah.
that you have positive frequencies and negative frequencies, right?
Mm-hmm.
So when you have negative frequencies, you're getting the inverse or the positive side. Because that's how the double-sided does be. So if you remember when you used to plot the double-sided, you had positive frequencies here and negative frequencies here. So for the phase, when they had the positive frequencies, all of them were up like this, some of them were down, which is okay. But when you went over to the negative part, you will have minus theta k, which is just the inverse of the positive. So
Yeah.
if you use a minus on one side, you're just gonna get the opposite of it on the other side. Nothing will change with your overall answer. But
Okay.
when you're doing the proof, assume you're asking with the proof itself. That is the specific thing you're asking for with the proof itself, or when you're
No, to be
using the form.
honest, I was asking what relation to use any form.
Right. So when you're using the form, you just use the plus.
Okay.
You're talking about this form here.
Yeah.
Let's use this one. Yeah, that is it. Don't overthink it. Just use that. If you wanted to get it double-sided, it would just be the inverse of all the faces. What plus will be minus, or what was minus will just turn to plus. And the frequencies
Yeah.
will be negative. So I hope I help. But when you're
Okay.
doing the
Thank you.
derivation, you will end up with a minus because you end up with this here after using
Mm-hmm.
compound angle. But when you remember that cos is an even function, that's how you will end up with this minus theta k here. Yeah, so you will get this when you're doing the proof. But because it's a single-sided spectrum, it will matter which side you use. Okay, just go and flip. You understand that, right? It don't matter
Yeah.
which one you use, because it is the same thing. Yeah? So if you look at it here, this positive, right? And this
Mm-hmm.
positive, you notice is either plus theta k or minus theta k.
Mm-hmm.
It don't matter which one you use because it's the same thing. It's still a single-sided spectrum because it's one side. Yeah? So that is why it misses for the O. So I'll let you know now when you do the proof, you're going to put a minus theta k. You could write or and just change it to a plus. But when you're doing the form in the question, just use the plus. That's all. Right? So I hope that helps.
Yeah. Dude. Thank you.
Anybody else have any other questions? All right, we'll turn into this because I too am tired. All right, so let's go through the. This one is more maths. So say going from the trig to the complex form of the Fourier series. So the first thing you have to write down is what is the trigonometric form. So f of t, f of x, however you just write it. So A naught and 2, which by now you should know is a DC component. Sum k is equal to 1 to infinity at ak cos, and for now I just write kx in my proof because going through all that 2 pi kf now, t thing is just too much, right? It's a proof. So the values inside are really going to change much. So, and that will be bk sine kx. Alright, so that's the trigonometric form of the Fourier series. Alright, so you could write your equations for a naught and 2 integral t0 plus t by alpha t dt. Write the equation for ak, so 2 on t integral t0 to t0 plus t. Okay, if anybody confused by t0 to t0 plus t, it just means across a period. Yeah, so that means because it's a periodic function. You can pick any period you want, right? So that's what I mean by from t0 to t0 plus t, which is a period. Anyway, so ak goes with cos, and then you have bk. I think I forget it. Anyway, so all I get now, so you're starting with the trigonometric form and you're trying to get into the exponential form. So the first thing I had to do is use Euler's. Alright, so you're trying to replace the cos here, the sine here, with something in the form of e, because obviously the complex exponentials in e. Right, so if you could think back anything that will convert cos and sine to exponents, you could use. So that is just Euler's. So the two equations for Euler's, you have e to the ix is cos x plus I sine x, and you have e to the minus ix is cos x minus I sine x. So these are the two equations that you have to use. And just like how you used to use the compound angle to get rid of either the sine or the cos, when you do that, you'll end up with two equations which you have to use. So you end up with cos x is e to the ix plus e to the minus ix on 2, and you'll end up with sine x is equal to e to the ix minus e to the minus ix on 2I. So don't forget the I in this one. Right, so that is the second major step. Right, so the other thing you have to do now is just replace the cos and the sine with respect to the trigonometric form. So you have f of t, so a naught and 2 stay, that will stay. Let's keep writing it back. So sum k is equal to 1 to infinity. So you add a ak there, and you replace the cos. So since it's cos kx, at the top it will just end up being e to the I kx plus e to the minus I kx, because I kx in the cos, on 2. And then you had plus sum k is equal to 1 to infinity, bk, and now you're replacing sine kx with the equation we just had up here. So you end up with e to the ix minus e to the minus ix on 2I. Alright, so that was that. Right? So the other thing that we have to get rid of is this I in the denominator. We don't want it there. Because when you're doing this proof, you're trying to get these two things here tied in to be the same thing. That's what you're trying to do. So you need to get it to be the same. So I want to get rid of this I here. So what I could do is multiply by 1, right? So when I hear anybody when math say multiply by 1, you're trying to multiply by something to get rid of something, but still keeping the overall value. So if I want to get rid of I can multiply by I on I. Yeah? So when you reduce it I by I squared is negative 1, right? So this will go, and you'll get a minus 2 at the bottom, and you could expand the I on top. So you can end up with IE to the IE to IX, right? And then minus IE to the minus IX, all on minus 2. And then you could carry the minus into the two terms. So you end up with, so this into that will give you a plus. So you write the minus IX first. And then this one here will get a minus. And then you put it back over 2. So I kind of overly break it down, but I just didn't want to confuse you. But there's the step here. So we want to use this here. Right, so now we just rewrite the whole thing again. That's why 8 marks. So sum k is equal to 1, infinity. So what I can do now, I will just expand out this one time just to save some steps. So ake to the ikx, I forget my k up here. Yeah, don't drop out the k will stay. Because the sign also had a k in it. Right, so here and then it will be minus ake to the minus ix. And we could put all this over 2. Right. And then you have the bk now. And we can expand it out. So remember we're using this one, not this one else anymore. Because I got rid of the I. So it'll be bk I e to the minus ix. And it'll be minus bk e to the ix. Just expanding this from the bk here. Remember this is this now. So all on 2. Alright, so we're here now. So the next thing we have to do now is just group the AK and BK. So you group an AK and a BK and a AK and a BK. But the thing I use to group it is this. So you group in all the E to the positive IKXs, and then you just go and group the minuses, which will be this BK here, and then this. Yeah, so you just group in a AK with a BK. So the thing is supposed to have a, right, so it's supposed to be a positive still. Yeah, kind of look at it. Yeah, come on, but this is positive up here. Alright, so when you expand, it's supposed to have a positive. Alright, so we're going good. So all you're gonna do is just group it. So f of t, a naught on 2, plus sum k is equal to 1 to infinity. So I like to write the e to the ikx outside, so I could group the inside easier. So I want AK, so I'll use this AK here, because it's positive. And then I need a BK, but have to be the positive one. So it will be minus BK here. And this will have an I. Remember, you're pulling out this here, right? So this one will have an I in it. And over 2. And it just do the same thing for the minus one. So I like that, right? So that E to the minus K X. Yeah, don't forget the K. Please don't forget the K. I keep forgetting my K. Right, so this one here, you need a AK, which is the minus for the AK. And then you need a BK, which is the minus. So it could be plus I BK on 2. Right, so we're there now. So mistakes I keep making and you will lose marks for, don't forget your K. Right, don't forget the K. Keep the K straight through. Even when I did this derivation here, I should have put the K in. Keep your K, keep the K. Right, keep the K straight through. So you see here, I don't have my K, you will lose marks for that. So put in your K. Make sure I'm putting your K. Right. Alright, so I think everything good here now. Right. So remember the goal I told you, you're trying to get these two to be the same. Right? So right now, this minus kicking in your foot. Because that's literally the only thing right now that preventing and this the negatives. So we had to do some manipulation. So we're almost done. Right? So you just go and invert the summation sign. So when you invert the summation, so you shift that from going from 1 to infinity, now to go from -1 to minus infinity. So when you shift that now, it will just shift the indexing. So instead of having positive k, you're going to put minus k. Alright, and then you'll see how the question kind of follow up. So A naught on 2. This first one staying the same. Nothing wrong with him. Okay, trying to get it positive, not really the minus. So nothing gonna happen with this. So you gotta write it back. So now you're gonna invert the summation. So you go from -1 to minus infinity. So when you invert this now, all the keys now be index and go and swap. So instead of it going positive, it will be negative. Okay, you swap the summation, which means you're swapping the indexes. So all the keys will become minus keys. Alright, so you can end up with A minus K plus IB minus K on 2. And then E, when you just have a minus here, so a minus and a minus will give you a plus. Right? That's right, IKX. But that kicks, okay, in real fun. No pun intended. So IKX. Alright? So we see how the E's looking good together now. So the last thing I had to do now, which is the cool part, remember AK is for even function and BK is for odd function. So we could use that law to get these things here to look like the first bracket, which is this here. So watch it. So since AK is an even function, we can use the rule. So for even function, A the minus K is the same as AK. Even is an even function. Is the same as saying f of x is equal to f of minus x. Same idea. And then bk is an odd function. And we can use the law for odd function. So b to the minus k is minus b of k. Yeah. So using these, which is basically the same as f of x, is minus f or minus x. Right? Same rule. So because of this, we get our final form of it, which is bringing everything together. So f of t, a naught on 2, plus the sum k is equal to 1 to infinity, ak minus I bk on 2. Remember, nothing happened to this one. E to the ikx, and I have plus the sum, this one going from -1 to minus infinity. So the a to the minus k become a k. And watch something. This b to the minus k now is now minus bk. And a plus and a minus will give you a minus. So we end up with minus I bk on 2 And obviously we just learned that this will be like that, right? And now we finally have these two being the same, which is the main goal of us going through all that stress. So now he going from infinity down to minus infinity. So you can bring the summations together. So now you're basically done. So you can say, so CK, the actual equation that I will use for CK is just this piece here, just AK minus IBK on 2. That is actually what CK is. Yeah? So from there now, you get a final form. And you just combine the summations. You're bringing them back together now. That is why you get for the exponential, you have to go from minus infinity to infinity. You kind of combine two summations to get one. So you combine the negative piece and the positive piece. And we all know 0 is your DC component. Yeah? So it don't have any cos or sine to any DC component, they're just a number. So look at it, it's going from minus infinity to minus 1. 0 there is a DC component, then you're going from 1 to infinity. So you can just combine the two together to get a nice final form. So you get f of t, a naught on 2. So the sum now going from minus infinity to infinity, and we know this is ck, and we have e to the I kx. Yeah, and that is it. You're done. Right, so just a recap. That was like 9 marks. So here, write your trigonometric form. I does use kx because if you're doing the proof, write in 2 pi kf naught t plus theta k over and over and over and over will get irritating fast. So I does just write kx as a proof. Right? So you write it, you write your forms, all that good and well. Then you're using Euler's, so there's Euler's. So these two. If you want to derive these, if you want to get cos x, you have to eliminate sin x. So you will plus for everything, and that is where you will end up with this here, because you end up with 2 cos x is the sum of these two, and if you want to get the sin x, you just get rid of the cos, which is subtracted, and you end up with this. That is where you end up with the 2i at the end. So you just use Euler's. Then you substitute cos and sine into the equation, and remember your indexing change now. So you have kx, right? So don't forget kx, right? A kx for everything. Don't lose silly marks like that, right? Then your goal right now, we can do this piece, take rid of the I, right? Remember your goal is to try to get both of them to be the same. So you have to get rid of this I, because he does not have an I, all right? So to do that, you just multiply by 1, which is just I squared is minus 1, so that way you get this. So you can actually sit down and try it out. And then after you make that substitution, your goal now is to group the e to the ix's and the e to the minus I kx's. Trying to group them separately. So one will have a ak and bk, and the next one will have a ak and a bk. One will be negative, and the next one will be plus. That's how I remember it. So it's minus plus e to the plus, and this one here minus. Now that's how I remember it. So one of the AKBK will be minus, and one of them will be plus. The one that is minus have the positive IKX, and the one that plus are the minus. Yeah, so why that good to do is that when you do the proof, if you realize that certain steps are looking weird, you can run back instead of doing the whole proof and realizing that you make a mistake quite up the road and to do the whole thing together. Just find cool ways to keep track if you're going correct throughout the proof at different levels. So when I reach this line, I know minus, plus, plus, minus. So I know I'm good. So after that now, after a group, you're trying to get rid of, sorry, you're trying to get he to look like him. So you're seeing two things. This plus is a problem and this minus is a problem. So to get rid of this minus here, you swap the summation. Like we get rid of this one here. That's where you get the positive. But now when you do that now, you end up with the AK and BK looking weird. Then to get rid of that one, you just use the fact that AK even, BK odd. You just use the lowers. And once you do that now, you get them to be the same, which is where you want it. And at the end, CK is this. Yeah. And then plug it in and you just group your summations back together. And that is the same thing, chugging it out over and over. Right? And that is the proof going from your trigonometric to your exponential form of the Fourier series. Right? So, any questions on it? All right. So, nice. It's like,
We don't
yeah,
have to work out CK.
not necessarily. It would be that would be the equivalent of us writing AK and BK here. I mean, it's not needed for the proof, but if you want to show off, by all means, go ahead. But I don't do that
Okay.
in my proof.
Because
I just get full marks. Hmm.
I was wondering because how many marks it was if they wanted.
No, no, they don't want that. If you want to, as I said, you could. If you want to show off and show that you know your stuff, but you're not gonna lose or gain marks for doing it. It's the equivalent of writing AK and BK here. You notice I use that in the proof anyway. That's there to show that I know my stuff. Right? So you're not going to gain or lose marks with. Right? Unless Miss specifically said to write it. But if you all want to be safe, you could. But I just stay this because there's a law. This is known. Right? This is known. Alright. Okay, so nice. Alright. So that your proof. Okay, so nice. So that's the first proof. They want to go from the trig to the harmonic. That's normally the easier one to do. Because just the triangle, substituting, compound angle, come back out. Yeah, that for that one is like 5-4 marks if you bring it. Because that is the most straightforward one if you're doing it. There's just a compound angle. Alright, so that should be good enough for most people. Alright, anybody have any questions on going from a trig to harmonic as on it? Any questions or everybody fairly like that one more than the trig to the exponential, which I did because it was nice. Alright, so I have 5 marks in the bag for this proof. So as I said, know your forms, know those two proofs I showed you just now, know your relationships, which is basically knowing the forms because it's just converting it. So it's just your relationships is AK, BK, CK, theta K, and Xa K. Yeah, so that is where everything does come back in. Really just remember it. That's what I do. Alright? So nice. So that was that. Cooking with gas. So that was the proof. Alright, so let's get into the good stuff. Alright, so I'll go into this. I just gonna assume that everybody knows how to integrate by parts. Word of advice, make sure you do everything before you do this question. Because this question is like real. I gotta be honest, I didn't finish all this when I did mine. And I still got like 23 out of my 25. Yeah, so she not gonna penalize you greatly if you didn't finish the question. She marking your method and your process. She does give away marks. Once she know that hey, you're going correct, you show your integration with the pieces, you start the integration, you didn't have enough time, she will give you a majority of the marks. Because she knows there's a lot to do. Right? So as I say, make sure all the other questions here, you make sure it's correct, you do everything good. If you want to go over the line, go over, make sure it's good and correct. And then when you finish that and you check over, then tackle this question if she bring it. If she bring a cosine sine form, yeah, that would be nice. But if she bring the graph form, I don't know how to approach it. All right, so I run through. So I'll go through this one and I'm gonna integrate. Because that obviously you know that I'm gonna take a look and everybody tired already. So I'll show you how to plot the graph and check to see if it even or odd. And then I will do the intervals and call it. So I'll do in this one and then which one that was? I think somebody was asking about the one with the costs. Oh, like the first one. Yeah, that is this one here. Because people ask me how to do the trig equation to get the roots. So I'll do those two, and once you do those two and the odd and even and the integration, um, question 7 and 8 from the tutorial, I have a video up on it already, so you can check it out. So that is the other two proofs that she could bring. If I'm being honest, she does not bring those proofs in the finals, but make sure you note. Alright, so other than that, you should be good. So let's run through this. So I'll do the equation, the line one first, and you go to that one, I'll call it 30. I'll just stick around for any questions. Alright, so we have this, there's a finals past paper question. She brought back the same question from the tutorial, which she will always do. Alright, so derived from first principles the magnitude and the phase spectrum of the signal. Anytime she asks you for magnitude and phase spectrum, 95% of the time the function either odd or even. She wouldn't ask you for a magnitude and a phase for a function that both even, neither even nor odd. Because that'll be way too much. Alright, so let's look to sketch this. So that's how I sketch mines. It may or may not make sense to you, but I'll try my best to show it in a way that makes sense. Right, so we have our graph is 2a capital T and T, and going from minus T and 4 to T and 4 and 0 otherwise. Remember, Fourier is for a periodic signal, and a period is normally from 0 to T. Yeah, or it could be, let me not tell it from 0 to T, because a lot of people are confused with a period is just where the function repeats itself over and over. That is what a period is, but it normally ends at T when you do any question. So I'm going to show you. So there's your y-axis here. So they said in the question that this is a line. So anytime you see something in the form of mx plus c, it's a straight line. So this here is basically m, and this is x. And the c, which is the y-intercept, is 0, which makes sense. So you'll know it will be going through 0. Right, so we're going up to t on 4, so I'll need space, I'll write it small. And then going back to minus t on 4. And there's a straight line cutting at 0. So dot dot, scroll up, and dot dot, and you draw a straight line. I'll see how best I could draw my straight line. And you have that, right? So the thing about it is that they said 0 otherwise. What do I mean by 0 otherwise? For this piece here, it have to end at t, because t is a period. 2 pi is a period. So therefore, all this here is 0 up to t. Right, follow me here. And the same thing for the negative part. Everything else is 0. Yeah? So now, you will want to plot more than one period of the same graph, right? So you could compare it, odd and even and whatever. So the trick is, when you reach the t, you're starting over. Treat that like if it's 0 all over again. Treat it like if it is, it's not 0. So if you're treating this as 0, you will go t on 4 above it, t on 4 below it, might have enough space. And you just repeat the same process. Let me just shift that t up a little bit because of space. Right, so t, you're going up, t on 4 again. Remember, you're trying to replicate this pattern you have here. So you're treating this t as 0. So when you was plotting it, it was t and 4 above the 0. You clearly see that. Same thing here, it will be t and 4 above t. So you can just whip out your calculator and it'll be like 1 plus 1 divided by 4. And I get 5 on 4. So we're going up to 5t on 4. And then you'll be like t subtract. Remember that way you get the negative part from. So it'll be 1 subtract 1 on 4. Okay, that's going backwards. And you get 3t on 4, which is, I don't want to erase that yellow, but I want to get rid of it. Okay, it irritates me. If I erase that green, I'm not going to be red X. Ah, boy. Nice. Right, so I'm trying to go back. So right here, that will be a 3t on 4. So you come down, pow, pow, remember you're treating this just like the first piece, so it had to go through t. And I'm going to see how good I can draw the straight line. Not drawn to any scale. Right, so now we have this going on here. So you draw one above, so let me see if we could draw one below, which is behind the y-axis, right? Remember, we had to compare for the odd and even. So same idea. So this minus t here, you're going to treat it like 0. Same, just rinse and repeat the same process. So I'm just give myself enough space to go back and forth. So this is minus t. I don't care what that is. I'm going to treat that like if it's my 0 when I repeat my period over and over. So I have to go here, up, and I have to go back. Same thing I did before. So I had a plus t on 4, so it'll be minus 1 plus 1 divided by 4. So you get minus 3t on 4, which is here. So you go up here, and then you have minus t on 4. Remember, you treated this like 0. That's why they're treated like 0 and you will know where it goes. So it could be minus 1 open, sorry, minus 1 subtract open bracket 1 divided by 4. So right, and you end up with minus 5t on 4, right? And here draw a dot. I treated this like 0, so I know it going through there. And draw a straight line as good as you can. Right? And obviously now, after this, after minus t is what? Minus 2t. And after t is 2t. And guess what you're going to do if you want it to continue? Treat it like 0 and rinse and repeat the same process. So it could be 2 on t plus t on 4, 2t minus t on 4. So it'll be 2 plus open bracket 1 divided by 4. You get 9t on 4 up. And then it'll be 2 subtract 1 on 4. And I get the bottom half. 7t up. Yeah, and then same thing. Pow, 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 dot, straight through, and they get an next period. And they got the same thing for the negative piece, and I get the same answer. And you rinse and repeat it forever and ever till that do you part. So for your exam, when you're doing it, I just normally plot 3. If she don't give you, so she normally give you 1 at 0, plot 1 above, and plot 1 below. Once you cover in a period. So now we're going to show you how to check for odd and even. So when you're checking for odd and even, this y-axis here, very important, right? And the cool thing about this y-axis here, you could technically make anywhere your y-axis once you cover in a period. So I'm going to show you what I mean by that. So let's say you didn't have anything. Let me draw this x so I can erase it after. So I'm going to write big. Let me say you didn't have this piece and the graph was just starting at the y-axis at 0 and it was going up. And you didn't want to draw no negative. Just use the positive, it's easier. So now, look at where the pattern repeated. So 0 here, and go into t. So t is a period, so you could draw a dummy y-axis here. Yeah? And now, you have this here going on, and t going up to 2t, remember there's a period, and t going back to 0. It's the same idea, you're just treating this as a dummy y-axis, but it's the same idea that you're working with. You're treating this like 0. Same idea, just shift it up. Why? Because you didn't have anything on the original y-axis on the negative side that you could swap. But it's the same thing because it's periodic, right? So all you're gonna do, same idea. So I run through this and then I'll try it with the original y-axis. So it's basically trial and error process of elimination. So we have even, so let me check to see if it's even. So for even f of x, which is everything on the right hand side of the y-axis, is equal to everything on the negative side or the left side of the y-axis, right? So you trying to find any point that breaking this law. Once you find one point that breaking the law, is no longer even. So let's check it and see. So across a period, the whole period, because what Miss will do, she will make sure it's starting up, it's starting even, and like be like, yeah man, it even, but it didn't cover the whole period. It had one piece there that was doing triplets that threw it off. So cover a whole period. So your period starting here and going straight to 2t. So you have to cover it, your whole thing, make sure it works for the entire period. If you are starting at 0, it will be from 0 to t, and then from 0 straight down to minus t. Cover a period on both sides. Full one. So since I use my dummy y-axis, I go in from t to 2t and t to 0. So let's go through. So we have all these points here. 0, 0, 0, 0, 0, 0, 0. Then all these points here. Then I reach the end of my period. So let's see if it given us the same points when I mirror it on the other side. If it even, right? So if it even now, watch how cool it is. You expect this point here, when I mirror it, you expect it to be here. Not so? But it's not. This point here, you expect it to be here, but it's not. This point here, you expect it to be here, but it's not. I don't need to go through all these iterations. I already find one point that break any law. So it make no sense continuing. If you wanted to go here, if it was a mirror that's on your next side, it's supposed to be here, but it's not. Alright, let me just mute the person because mic is on. I'm not watching cricket, am I? Mm. Yeah, but you watch cricket after. Anyway, so we have this point here, we expect it to be underneath, but it's not. So by process of elimination, we already find one point that breaking it. So this function is not even. Yeah? So now we have to try it for odd. And I'll use black. So for odd, f of x, which is what I have on here, right hand side will equal to minus f of minus x. Basically just flip. Wherever positive is now negative on the other side, and wherever negative, positive, positive, negative, we just flip it. So let's see if we had a flippy flippy thing going on. So we're here. So we expect this here to be this. Look at nice. But don't stop, don't get excited. Finish it. So here is here. Alright, everything I see in the pattern. Alright, you're good. These 0 pieces, well if it's 0 here, it's 0 here. Everything good. Alright, nice. You reach here now. So he going up to here. You expect it to be going up. Where? Good, nice. Then here, you expect it to be on top. Hey, look at that. And just like that, we finish. We finish the period. So I'm not falling for mistakes. So therefore, this is 100% an odd function because it obeys the law of an odd function where f of x is the same as minus f of minus x. It just flipped. Yeah, it just flipped. All right, and then I'm gonna try it with the real x-axis, which is most likely how I'm gonna show you all it. But as I said, you could shift your y-axis anywhere and repeat the same thought process. A period up, a period below, cut it off, check to see if you find a point that break in any of the lows. Right, so now my period going from 0 to t and then 0 to minus t. Right, so going up, if it even, power, it's not even. Alright, if I find a point that break in the low, I don't need to do more, it's not even. Then check for odd. Here, supposed to be here. Good. I mean, you already know where it is there, but I'll just show you that. You could use it. 0, 0, 0, 0, negative, positive, shift down, you reach minus t, positive t, we cover the period on both sides, so it odd. Yeah? And I saw the check. So you just draw a period above, a period below. If she start at 0, it could either go backwards and draw a period before the y-axis, or it could just draw a period after the period that she drew for you and repeat the same process. If she draw more periods for you, you get through. Just pick at the end of the pattern finishing, draw your y-axis and compare the right and the left. Same thought process. Let's see if I get our next one. Let me see. Oh, this was the right. This one here. So let's see if we could use. But we just so that she start at 0, which is okay. So the period is here because we can clearly see the pattern repeated. So slap down dummy y-axis. We compare. Once you find a point that breaking, don't go more. So checking for even. So if it's even, I expect here to be here, and it's not. So it's not even. Check for odd. So you expect here to be here, but it's not. So it's neither even nor odd. So you have to calculate AK and BK. Yeah, that is how the graph itself does operate when you do any questions. Alright, if I was to shift the y-axis from inside of here, shift it up, quite up here, for no known reason. Same idea, check for even. You expect here to be here, it's not. Check for odd, you expect this to be here, it's not. So it's neither even nor odd. Same thing over and over. Alright, and last thing with odd and even, so you have AK and BK. AK goes with cos, BK goes with sine. AK, cos is an even function, BK, sine is a odd function. AK, even, BK, odd. AK, even, BK, odd. So if a function odd, AK is 0 for all k. And if a function even, BK is 0 for all k. So AK, so for odd, AK is 0, and for even, BK is 0. Alright, so, and that will help you to eliminate some of the, again, free marks for stating that, but it also saves you the stress of actually having to integrate two things that are not needed. Right, so that's why let's check to see if something even or odd. Let's have how we, plenty of people have different ways, but that's just how I just do it. I just move my y-axis and check to see if the points align it. Check for odd, check for even, across the period. Once it break for one, I don't need to go across it, already break. But if I notice it working, I have to check for the whole period to make sure that I'm not trying to trick more. Because I tell you, she could start it, good even, good odd, and you could be like, yeah man, it even, but you didn't check the whole period, and you lose your marks. Because then you go come out the exam and you could be like, where you get even or odd? But they could be like, no, boy, remember it had a piece there. And they could be like, I never see that far because you get too excited. So make sure and cover your period on both sides. Make sure the law working for both of them, and it will be good. Alright, so that's how to check for even and odd. Alright, so back to what I was doing. So, right. The next thing I do now is you integrate. Would have advised if the shape geometric, just use your normal primary school equations, base by height, same thing, length by breadth. Just use it, it's easier to do that. But if you're doing that now, A naught and 2 is 1 on t by the integral across a period of f of t dt, right? So this piece here is basically you just doing your normal area, your length by breadth and whatever, but the final answer you still have to multiply it by t. So it's 1 on t by the total area on the graph. So be careful if you're using that. Always try to run away from integration as much as you could, unless you have to. Alright, so triangle, half base by height, same idea. Alright, so let me just run through before you go integrate this. So since it's across a period, for this piece here, you had to integrate from 0 to t on 4, nothing, and then from minus, and then from, sorry, 3t on 4 to t, and that will cover your period. So since with this one, we know that it's odd. So since it's odd, we have to calculate bk, because it's not even, so it has no ak terms. So you have to integrate from 0 to t on 4, f of t, and the f of t part is what will give people trouble. So for f of t, right, remember, this is a straight line, right? It's legit a straight line. So you have to get the equation of the line itself. But luckily for y'all, she already gave you it. So she kind of saved you the stress of having to actually get it. Okay, you notice she never gave you amplitude or how the graph going. So you wouldn't really know what it is. Alright? So since she already gave you the equation, the line, you could just use that as f of t. Yeah, so it will be asking a question. Is it the area above and below? Yeah. The whole thing. So you got half base by height for this one, and half base by height for this, and they add on the top. So luckily for you all, in this case here, I don't think it will have a DC component. A naught and 2 will be 0. So how it does know that is that if the area above the x-axis is equal to the area below, it will cancel. Because a positive area and a negative area, when you add it up, you'll get 0. So that's how it does know if it